Okay, so in this question we have to enlarge this shape here by a scale factor of half with the centre of enlargement at 0,2. So let's just label up the object to start with. And first of all, we need to label the vertices of this shape. So it's the vertices that define the shape and that we're going to use to find the image of enlargement. So A, B, C and D are crucial. Next thing, the centre of enlargement. Well, the centre of enlargement is given at 0,2. So 0 along, 2 up. So that's going to be here. And there are two ways of solving this question, two strongly mathematical ways. You could do it visually. But first, before we do that, let's have a look at the examiner's remarks. So the examiners say that this question was generally well answered. The most common error was to use 20, 21 or 00 as the centre of enlargement. But apart from that, people generally understand what to do here. So that's good news. The first thing that they understand then is that to enlarge a shape by scale factor of half doesn't actually mean to make it bigger. A fractional scale factor is going to make the image of the object in fact smaller. So enlarge can mean contract, so dilate or contract. So actually what we're going to do is shrink this down with a scale factor of a half, and that's the first thing I guess that people understood. And the second thing was they were able to position it correctly, maybe because they understand this idea of drawing up from the centre of enlargement construction lines to all the vertices on the object. Now, before we actually do something like that, is there a way of doing it just by looking at the coordinates? Well, the centre of enlargement in fact isn't at the origin, which usually prohibits this, but it would be very easy with this particular diagram to just relabel the axes so that the centre of enlargement is at the origin. So I'm going to just do that just to start with. Perfectly okay to do that. Why not just cancel, in other words, all of these? Okay, and just relabel the y-axis so that this becomes now 0, 1, 2. We only need to, in fact, number this up to 10, because that's the top of our object, and we can leave the x-axis as it is because we've already got the x-coordinate at the centre of enlargement. So now that we've renumbered our axes and we have the centre of enlargement at the origin now, so the centre of enlargement is now at 0, 0, we can go ahead and look at those coordinates. So let's start with A. Well, A is at 6, 8 in our new coordinate system. B is at 10, 6. C is at 14, 8. And D, well, that's at 10, 10. So with an enlargement, we multiply the scale factor, so the x, in other words, of the image is the scale factor, which in this case is a half, times the x-coordinate of the object. Similarly with the y-coordinate of the image, that's also the scale factor, half, times the y-coordinate of the object. So that's the little formula that we use, and so now we can go ahead and derive A prime, B prime, C prime and D prime, let's call them. So A prime has got to be half of 6, so that's 3, and half of 8, so that's 4. B prime must be half of 10, 5, half of 6, 3. C prime, half of 14, 7, half of 8, 4. And D prime is at half of 10, 5, and half of 10 again, 5. Okay, now we just need to plot these on our graph. So A prime is at 3, 4, 3, 4. Where are we? 3, 4. B prime, let's just label that A prime. B prime is at 5, 3, so 5, 3. B prime. C prime is at 7, 4. And D prime is at 5, 5. 5, 5. So let's join these together. And we've completed the question. We've enlarged the shape by a scale factor of half with the centre of enlargement at 0, 0 in the old scheme. But if we remove this now, we'll have it at 0, 2. So in a way, what we're doing when we renumber like that is we're beating the system. We're saying we're not going to accept the centre of enlargement not being at the origin, and we get the image in exactly the right place. Okay, but what if we didn't want to do that? Then we have to turn to a geometric solution. And with a geometric solution, what we're going to do is work with vectors rather than coordinates. So let's just erase this and start over again. Okay, so this time what I want to do is I want to draw vectors from the centre of enlargement, which we can't really call 0, let's call it E. So I want to draw a vector from the centre of enlargement to all of the vertices, in fact. So let's just do that. So a vector from E to A, and that. A vector from E to B, E to C, and E to D. Okay, so that's drawn the vectors on the diagram. Now what I'm going to do is, let's keep with the same colour pen so you can see the difference between these two methods. So we've got E to A. Well, we need to be careful when we're looking at the y component, but the x component, the first component if you like, of the vector is going to be the same as the x-axis. So 6 along is going to be our first component of that vector. 6 along then, and not 10 up, because we've got to subtract 2. So 10, subtract 2, so 6 along and 8 up is E to A. Now if E to A is at 6, 8, then A prime must be at half E to A. So half the vector, half E to A, is going to give us the location. So half of 6, 3, half of 8, 4. So that's going to be the location now of A prime. So let's have a look at where A prime is. So A prime is 3 along, 4 up. So that's going to take us to here. And now we can label that A prime. There we go. So that's our first one done. Let's move on to E to B. So E to B, but not the coordinates of B. The E to B is the vector. So we've got 10 along and 8 minus 2, 6 up, or 6 in the y direction if you like. Therefore half E to B is going to be half of 10, 5, half of 6, 3. So we've got a vector for E to B at 5, 3. So half E to B is at 5, 3. So 5 along and 3 up is going to take us to here. So that's the location of B. Okay. E to C then. E to C is going to be 14 along and 10 minus 2, 8 up. So half E to C is going to be half of 14, 7, half of 8, 4. Okay, so 7 along, 4 up. It's going to take us to this point here. So that's the position of C prime. Finally, E to D. So E to D is 10 along and 12 minus 2, 10 up. Half of E to D then is going to be half of 10, 5, half of 10, 5, so 5, 5. So we've got 5 along from the centre of enlargement, and 5 up takes us to here, which we can mark as D prime. So finally, just as before, we can draw these together like that. Okay.